my speaker on. I think somebody's already sending some stuff. Thank you, Dax. Dax is already on this morning. That is awesome. No, he's just on. Yep, I gotta watch. I love it. That's so funny. Oh, he's just on. Yeah, I can't play that. I'll get a strike. Good morning, Max. I saw you on Discord before I saw you in chat. That's hilarious. Yes, actually that came up. You came up at dinner last night. I was telling everyone. I told him the one about the Python basics, the PB, and Sam brings the jelly. Yeah, they all like that. All right, so today's topic. So we're gonna be focused on. I may be a little bit distracted because we got a lot going on around here. Storm heading towards my parents, so I've been getting updates from them. So I may be. I won't drop, but I'm probably not 100% here. I'm pulled in a bunch of different directions, and we got some drama going around here too. Just like always, it's never dull at my place. So all right, so this one, if I'm taking this in properly, let's go through. I have not put this in chat yet, so let's do that. There we are. So given an integer array nums and an integer k, return true if there are two distinct indices, I and j, in the array such that nums I equivalent to nums j and absolute value I minus j less than or equal to k. Always, Dex. So let's make sure that, one, I'm interpreting this of what it is meant to be. So I have the link for the LinkedIn or the Leetcode. Sorry, yeah, I have a meeting today. I think we can squeeze in this problem and then me get ready. Don't know what's going to happen from this meeting. Just kind of a meet and greet for some stuff. But all right. So we're giving an array. So basically the way that I interpret this is how close are these on the indices, and basically k is the delta difference in their distance. That's my interpretation of this. Let me check the color and everything, and I need to hurry up, and we'll get started here, and then we'll record a video. How the teeth are all right. So before the lighting gets bad, we may quickly do a video. I don't need to, and I gotta drink this morning that has no lid, so that scares the ever-living life out of me. Was not able to solve the solution for this completion yesterday. I was getting some weird answers. So all right, we may do this one right real fast. Let me hurry up and do this while I have some good lighting. That looks pretty good. Yeah, teeth are good. Little spot. All right. Whoa. I thought that fit better. All right. Let me knock this out real fast, and then we'll get going on our problem. Understanding the anatomy of your object. Hi, everybody. This is Sam with Python Basics. So here's been a key aspect that we've really been honing in on during our live streams. Understanding the anatomy of our object. So what in the world does that mean? Well, what has been a theme during our live streams is going from being solved to being optimized. And the more you understand the object that maybe you're creating, or there is an object that can achieve the goal that you're hoping to in a very efficient manner. So if you, it's a branch of understanding your problem. So if you understand, so an object that you're working with, or another way that I like to describe it is the tool. A tool that you're using. What is this tool capable of? What are all its features? What problems can it solve for you? And the more you understand, and we even talked about this with communication. So the more you understand, the better you can use it. So it's getting granular, it's going backwards, it's dissecting. That's where I kind of came up with the term anatomy, because we were going back and forth talking about dissecting the object. What is it really getting you? What is it getting you to? What does it appear like? We've also talked about using the type function. I'm getting this error. Why am I getting this error? Oh, it's a different type of object than I was expecting. So understanding what is available for you to use is step one. But go down a layer. Go down a layer. How does it work? What will be a result if I do X to it? Wait a second, then I can do this to it, and then I can unpack, or I can zip, or all of these features. And if you go backwards and you get more basic, more granular, these problems begin to present themselves with a solution. So real quick video today. Make sure you're jumping. If this is the first time you're being here, so glad to have you watching this video. Make sure you're hitting the subscribe button and the notification bell. And there's a link down below for our Discord server. So make sure you're joining that to get all the support that you need and deserve. But as always, everyone, thank you so much for watching. Stay tuned, and we'll see you next time. Bye. All right, there we go. Hopefully I didn't lose everybody. All right, so that one's done. Did I move it, or yeah, that's done? Excuse me. All right, we can move that down here. And there's a Pascal triangle 2 also available. So all right, let's get these going. I think I'm understanding, because this is also a theme. No, there we are. Is make sure you understand the problem. Make sure you really understand the problem, because you can get into a whole world of issues. Yesterday, I was trying to solve a problem that didn't exist, and Vinky was being very patient and very polite, going, I don't think this is what we're doing today. But, yeah, so there we are. So let's look at this again and reread this. All right, given an array, an integer array, nums. So this is our array object and an integer k. So we're going to have an array and an integer. All right, I'm good with that. Return true if there are two distinct indices, and indices I and j, in the array, such that indices I, indices j, those objects at those indices are equivalent. That's the way that needs to be read. And so more than one condition, and basically the absolute value of you subtracting them from each other. All right, well, let me not be sloppy. I first, j second. Is there a way to get that? Let's make sure j equals 8. So abs. If you don't know, the ABS is absolute value. So if it's negative, you turn it positive. So it's you flip it. You flip the no number line, and you always make it positive. So I minus j. So I want to check something. Should still be 4. All right, but we need to make this. So, and also, so basically the way that I look at this is the distance less than k? And again, sometimes my interpretation speeds things up, sometimes it slows it down. But again, just like I just talked about, do you understand the problem? Do you really understand the problem? Dax can speak to this, speaking with stakeholders. And especially business people or decision makers, they see it in their head. I know Dax can speak to this. If you're talking with somebody and they're trying to share their vision, they need to have I almost said a vision board. They need to have some sort of illustration to draw it out so everybody has the same idea, because what's in somebody's head is very, very, very hard to communicate and get out. So, all right. So basically, this is the distance. So right now, we have 1 and 1. So index 0, index 1, index 2, index 3. And k is 3. So 3 minus 0 is 3. There's our distance. There's our delta. So 3 is less than or equal to here. So that's step 1. Well, actually, that'd be like the last step. But here, I want you to... the instructions are very explicit, so you have to pay very close attention. Hang on. I need to respond. Can't spell today. I can't tell if I'm getting sloppier with my fingers or if like the keyboard shrank a little bit on my phone. All right, so 2 distinct. So right now, I think that's decision 1, because what happens if we got an array of just 1? We could have, depends on how we design it. Because again, we have to understand, how is our human brain making this decision? And then we have to write it and articulate it. So after we do probably another video tomorrow of a Leetcode, I want to talk about this so bad, because our brains fill in the blanks so much, and I think that's why beginners have such a hard time, is because it's not that you can't program, you don't understand that your brain is doing so much more of the lifting than you think it is. All right, so dissecting it and make it into teeny tiny pieces. So the first thing is nums. Nums has to be greater than 2. All right, and this k, okay, so here, and see, already saying, so they're going to give us a num length is going to be 1. So that's automatically going to be false, because it has to be 2 distinct indices. 2 distinct indices. So problem 1. What I'm sitting here is, do I want to do false first or else? I don't know which. So I'm just going to pick. So if nums less than 2, print, we're going to do this as a function so we don't have to change a bunch of stuff in case there are a ton of returns in here, because I'm feeling this is a lot of returns here. But I'm glad everyone's here today. If there's a few more individuals on the stream that I haven't put anything into chat, just say hey. I just want to know if there's anyone here that I haven't seen before, and I'm very curious of the time of day it is where you are. You don't have to tell me where you are, just tell me the time of day, and I can get a general idea where you are on the planet. That's what this whole process of me doing these live streams and building this community of how many people. It's really opened my eyes to how big everything is. So return, so if it's less than 0, it's false. Boom. Else, we're going to do everything else. So now we need to begin finding. So this one is, okay, true. Okay. Aha. All right. So let's take a second and take a peek at, I think you know. Yes, I do know. Thank you, Dax. Let's see. So right now, I can tell we got to be very specific. Have you thought about turning off YouTube ads during a live stream and reestablish them for the viewer's recording version? Oh, that's an interesting idea, Dax. I would need to look into that. Hang on. Let me see. Let me see if I can do that. Let's see. There we are. That's a great idea, Dax. All right. Vanky, good morning or good day. How are you? All right. So let me know. All right. So I turned off ads during the live stream. That's a good idea, Dax. And then I'll turn it back on during after it publishes. All right. Okay. We can do that because Dax says that they might be leaving. That's a great point. Thank you, Dax. This is coffee and my protein shake all mixed in. All right. So I can we're taking a pause here. As we can see, because we can't pause. We're not going to stop once we find a match. Because if we were to pause right when we found a match of two indices, it would fail. Because these are a distance of 2. But it's like, aha, here are two indices that are equivalent and they're side by side. So then it would match. So I can already, Leetcode is doing its awesomeness of becoming very challenging. And then here we are with fantastic. Technically evening right here. Got it. I had a feeling it was. You're probably technically evening, so 5, 6. So I'm minus 5 off Zulu right now, maybe 6 off Zulu. So then you're 5 more. So you're 10 hours ahead of me. So no. 9 hours ahead of me, something like that, 5 or 6 where you are. Okay. All right. So we need to iterate through this, which I hate iterating through because that means a for loop. That means slow. And then if we need multiple pointers, that means multiple iterations. That means slower. Because linear, we've been talking about time complexity. But we also said that we're going to solve this, then improve time complexity. So let's get it to work. So for... Okay, that's kind of funny. Now that's the thing about the international date line that kind of messes with me. That if you travel around the planet one direction, you lose a day. If you travel around the other direction, you gain a day. That messes me up so bad. My father-in-law, when he was on on a boat traveling west. They crossed the international date line, and he missed Christmas. He was very, very upset. He missed Christmas dinner. He was very upset. And I was like, wait a minute, how does that, bud? You crossed the international date line, and you are that's the date. That's where we had to pick one. Just like in programming, we had to make a decision. So that's where it is. All right. I remember it was Around the World in 80 Days. I remember watching that movie as a kid. All right. So else for so we need to pick I and J. Oh, wait a second. Here we go. So K, we're not going to need to. All right, so walk with me through this. Venki supervised this thought. We don't need to iterate everything because we have a constraint of 2. So once we hit our constraint of whatever K is, then if they don't match, then we move our other pointer. Okay, here we go. Half optimization, half problem solving as we go through this. All right. So we're going to double iterate, but not to an extent, with a limit of K. So let me visualize what and why storyboard. I don't know why I couldn't get to storyboard. Storyboard was floating around in my head. All right, so let's do this one because here we are. All right, copy and paste. Don't need that big. All right, and K is, let's bring K over here. K for this one is 1. K equals 1. All right, now back to the brush. So here we are. So K is 1. So I start here. I can move over 1 and look. So it has to be, so that's my constraint. Did I just draw that straight line? No, I did not. I just drew that line that straight. Okay, come on, that was pretty impressive. I just drew that straight of a line. Nothing? I don't get a... See, now I can't even come close to... Nobody was impressed with that. Now I can't... Now I'm trying to do a straight line, and now I can't. Okay, hang on. Okay, that's awful. One more, and then I'll go back. Okay, I'm done. All right. So basically, my constraint is here. So I will always be looking here and here. Now, okay. Yes, we're going to iterate, but we're only going to double iterate to the limit of K. So in this constraint, I'm given this array, and I'm constantly looking at these two. There we are. All right, does that make sense? Now we just have to get that out. So there's my solution. Instead of iterating through the entire list and then going, oh, hey, is it less? I found this and this. Is it less than this? Too far down the path. We're going to look here, look here, look here, stop. Look here, look here, look here, stop. And then iterate through. And unless we find it true, and then we break. So, all right, let's try. Now let's see if we can get that out of here. You gotta need a smooth mouse pad. You gotta, yeah. I need to get a pen. It's not the pad. It's me and my old shaky hands. So let's see if let's try it again. Back brush. That's so bad. All right, let's see if we can get this out. Actually, I think one of my kids has a drawing pad with a pen. All right, so I'm not going to get to use my standard I and J. So for I in nums, print I. And what are we going to call this? I and J. I def I underscore J. Have no idea. I'm just making that. I'm awful with. If you haven't noticed, I'm awful with variables. Variable names. Okay. And copy. Oh shoot! And we got to pass in K. Is this the first time we've passed in more than one variable in our? Does everyone feel comfortable with creating a function that has more than one variable? Let's see. Print I underscore J nums K. Okay. I already had a problem. So I'm fixing the length of my first double check. So it has to be less, it has to be greater than 1 because it has to be 2. So the reason why this first one is here, if you just joined us and you haven't seen, has to be 2 distinct indices. So if it's 2 distinct indices, it has to be 2 objects in the list. It has to be, so the length has to be greater than 1. All right. So here we are. So this is, you don't have to check anything else. If it's got 1 object in it, it already fails because that is check 1. Now, we need to verbalize this and storyboard it. We storyboarded it. Now we got to get it out, the actual algorithm of how this is going to go. So now what I'm going to do is I want to increment K Do I need a counter every time? Yep. Counter equals 1. So while counter is less than so here I know I'm going to have an issue, and what I'm trying to visualize is it going to be less than K or less than or equal to K? So you're always going to have an issue with being 1. Where am I adding the 1? Where am I checking the 1? Am I going to add it after? I'm going to add it before. So that was a poor explanation, but let me just try to start and then I'll explain it. While counter is less than K, this is my first start. I know my premise. I know the soul of this is right, but I don't know if the actual math is right. So let's go back to our right here. So I have my counter, and basically, yes, with 1, this is basically a hard code, but I've got to make this dynamic. So if this was 5. Oh. 5. That's interesting. Did not know, was not expecting that. So put a 5 over the 1. Delete. Five. There. So I would need to be checking for each indices if for the length of 5, for a length of 5. So if I was given k with this, you need to then have a defense program against this continuously checking. So just trying to think of all of the outliers or any crazy ideas that can check. So we need to be continuously checking. What about when both indices are equivalent or equal? When both index are equal, like I and j, then absolute 0 would be 0, right? Yes, they have to be. They can't be the same. They have to be two distinct. Sorry if I read through that fast, or sorry if I didn't actually read it, because we know that that is a possibility. So yes, it has to be two different indices. They cannot be the same. And are you saying it would? That is another way to do it, but I think we're solving all of that with this, because if it's a length of 1, then it automatically fails. But then, so let's look at. So what I'm doing is let me show you what I kind of had in mind here, as I can already feel Leetcode doing something like this. K. You think they would do something like that? But it violates their own constraint. Yep, look at this. Or K. Bingo. So this is a fail. This is why reading all the instructions are very, very important. So ADHD's written instructions, awful. Okay. So now, thank you, Venki. Or K less than 1. Less than 1 returns. So let's go over. So if k is 0, that means the distance between the two of them is 0. That means it's the same indices. So it can't be, because first rule has to be two distinct indices. So if the k is 0, that means it's the same indice. It has to be a fail. That's my interpretation of what this is. Because less than or equal to k. Because 1's fine, that means it's off by 1. It's in front or in back, which forward you wouldn't have to check anymore. All right. And then we also need to figure out a way later that once we find it, they are equivalent, and it is less than k, which we're going to actually control our constraint of less than k by only searching k distance. We're basically going to be slicing and iterating through and only be looking there, here, or whatever the length of k is. First look at this one, then look inside this one, then look inside this one. Okay, no. Then we're going to start here, and move on. All right. I think that is, so Vinky, great catch. So we needed to add this. So, or if you've not seen an or before, think about, it's literally the English of, is that one wrong or is that one wrong? So if either. And means it has to be both. So you have more than one constraint. We have optional constraints. I only need one of these to be true. That's it. And you do this with an or keyword. So actually, while we're here, and we do have couple of people just drop it in. So help, or it's got a whole bunch of documentation. Let's see where to go. Or a Boolean operation, or test. And test or test. The context of the Boolean operation is also an expression or used to control flow statements. Following the values are interpreted as false, none, numerical values, all types. This is a lot of wordiness for I only need one of these. Sorry, guys. I just got a real bad ring. I only need one of these to be true. Just one of them. All right. And if one of these is true, that means the whole thing is false. All right. So now we're going to be starting at the first indices with our I. So let's not confuse our I with our I and J. So our counter, do we want to make counter J? Yeah. Okay, well, J, let's kind of stick so we don't have to get crazy and we don't get lost in our variables. You can easily get lost in your variables and trying to track this. All right, so while J, if nums I, here we go, equivalent, did I put that, is equivalent to nums I plus J. So J is also going to be our increment over, because let's get out of here. And sorry. And undo. All right, so this is the way we're going to handle this. Is I is going to be first time through. Let's get in the habit of thinking about this as our first time through. So I is going to be 0 and J is going to be 1 automatically. So it's not going to be index 1. It's going to be our augment. And we're going to do this while our augment or our K limit. So we're doing a constraint on our K. So K is how far can you look? How far can our distance be between the two of these? So that's our constraint of how we're going to do this. So don't think about J in this example as our index, but we're going to be incrementing I by J. So let's get the hang of this. So I, and then I plus J. I and I plus J. So then now these are not the same. So then while J is okay, hang on. If they're equivalent, then return true. Whoa. Else increment J by 1. And you're going to do this until while J is less than K. So let's get a larger list so we can look at this. Picture's worth 1,000 words. A video's worth 1,000,000. Let's go back over to our picture. Let's get this. And I'll try to really visualize what I'm doing. And K is 2. K is equal to 2. We don't need this right here. And let's move this over. So, all right. Here and it could be here or here. This is my gap. This is the biggest this gap can be because the distance, the delta, is 2. So I'm going to be checking first here, then here. This is my augment of k. My biggest augmentation, my biggest delta is 2. So if it is not in here, we're going to stop and move over to this index. That's what we're doing here. So I'm going to be iterating through the entire list, the nums. And when we know how to do that, we have nums. And for I, let's bring this in. Nums. Okay, what? Oh. Be careful what you're running, because it will run exactly what you think. All right. Somebody just... Bingo. It is a variation of the sliding window with the constraint of how much the sliding window slides. Exactly. 100%. So, Venki. So, what Venki's saying is we've done the sliding window problems before. And there, when you get to the point where you've seen everything, the eeriness between programming and jiu-jitsu is becoming really, really creepy. And then you're going to have slight variations of this, but the building blocks are all the same. So we now have a sliding window with a constraint. So right now k is 2. Let's run this into. So let me make sure I got my cup with no lid on it. So I got to make sure. And k. So I'm sitting here. So I'm going to iterate as I'm iterating through I in nums print I. So I'm iterating through this list. And my other pointer, my j, my augmentation. So it's not an indices yet. It is because I'm taking j and I'm moving it over. Because it has to start at 1 because it can't be the same. I'm not starting at 0 because it can't be the same indices. So right now, j doesn't care where I is. It is I plus 1. Okay. And if you looked at the error that I just did, type error. Just like our video that I just talked about. Make sure you understand your object, the anatomy of your object. So why'd I just fail with this? And look, these are important because if you're like me, and I think you're here because you are like me, so you're probably pretty intelligent, but probably with some OCD. Oh yeah, I have OCD too, but I don't think you can have ADHD without being OCD because I think it's the same wiring in your brain. So you're here because we're similar. So here's the detraction. We're going to make mistakes like this, but we're also going to learn from them. And those learnings, we have outstanding muscle memory. We're going to make a lot of mistakes, but our brains are so fast that we begin to see them all the time. And we know exactly. I've seen this mistake probably thousands of times. And then I don't have to investigate because I'm like, I know what I did. Anybody got any guesses of what mistake that I'm doing? And it's right. It's in collaboration with this because it's failing on this line. And the problem is initiating here. Anybody have any ideas? So I'm slicing, but I'm also iterating through the list. I'm indexing. Anybody see it yet? So I'm mixing and matching. I'm mixing objects with indices. This is exactly like the topic that I said. Make sure that you have and understand what you are doing and what you mean to be doing. So I was, and again, do not I'm going to say this is a do not, and I'm going to say this is a do. Do not take offense when your solution is wrong. And do make sure you separate yourself from your solution. You are not the solution, and the solution is not you. So I made a mistake. Ooh. So do not berate yourself. Just go, ooh, I'm going to learn something. That's how when you get a type error, when you get an exception and it throws an error, you should be excited because you're about to get a whole lot smarter. All right, so I got a whole lot smarter learning to program, and I can type a lot faster. I know I can't type better, but I can type faster. All right, so now let's run this and see if it runs. I mean, not knock my drink over. All right, I still have an issue, so let's figure out why. It's failing here. Okay. Let's see. Let's comment this out and make sure that this is running exactly like we think. Print I. All right, so it's completely contained down here. And I got the same error. Int object is not subscriptable. Int object, int object, int object. Okay. Anybody else see it? This is now the other downside. But this is why I like Spider. So I should have a whole bunch of boop boop. Missing an S. Aha. Okay. So now I'm out of range. So then I need to... We could defend against this pretty quick. I can't remember the rule if we have to have an accept. We're gonna try it without it and see if it... Yep. It's throwing up. It needs. We make 3 corrections every second while driving. Is that it? Without correcting, you end up in a ditch. Correcting code is iterating is a normal part of the process. 100%. Is that on average that we do make 3 corrections every second while driving? That is insane. I've never heard that. Not surprised by it. But that's exactly... Oh. That's exactly what I'm talking about our brains doing so much more. Oh, my kids, you used to tell me this one. You're breathing manually now. You don't think like breathing. You don't think about it, and then now you're like, wait a minute. Now I'm actually controlling my breathing. All right. Okay. Now I'm stuck in an infinite loop. Continue. All right, so why? Try that if true, else. So if I throw... If that throws an error, break. All right. Per chat GPT. Okay. Hey, I don't know. Sometimes... Return none. Return false. Let's see. This is throwing. I return none. Okay, let's. Okay, that was supposed to be false. So now let's see. This one's supposed to be true. I believe so. Okay, so we have a problem. This is supposed to be true. Let's see. So am I resetting? Let's see if I hit here at all. I like to do that to see if We did not get down to here at all. All right. So 0, 0, 1, 2, false. Okay. Let's see. 0. So I'm not getting my last. We're not getting the last indices. That's a problem. So, all right. So the first thing that's jumping out to me is we're not getting to 0, 1, 2, 3. So it's quitting before. So even before, this is probably the likelihood of this being all correct is low. Use a for loop instead of a while loop. Okay. So for I in range K, 1 through K, like it. All right. For J in range 1 through K, K plus 1. We still going to have an issue here. Vinky, you're good. All right. So, well, now I'm annoyed. I can't do that with a. I love that. So you don't need a break because we're using return. So everybody knows that when you hit a return, your function stops. So that's an important thing about the anatomy of. Now also, this is an order of operations. So you have to make sure, like I put this print yes. And see, okay, so this is perfect because it doesn't have to move out of 0 because we're going through here. All right, let's come down. Is it this one? Awesome. 0, 1, and then I also want, yep, in check if you are with invalid index. Yep, in check. Exactly. So, all right, more than one way to skin a cat. So we have more control over the while because apparently I wasn't envisioning this correctly. So let's go over this line right here. Ventkey solve. We need to start having a session called Ventkey solves. I love it. All right. So we're controlling our slidiness with this for loop. So we'll use, are we on this one? We're on this one. Our slidiness. So our for loop, so inside of this, just in case there are individuals here who are not familiar with the anatomy of a range function. Range and slicing, same fundamentals. So, all right. It can take up to 3 objects. Same thing like slicing. A start, a stop, and a step. Start position, start index, start object, inclusive. It will start at that point. If you pass in a second object, this is the endpoint, but it is exclusive. So you will go right up into 4, but 4 is not included. And let's just do this. So if I were to do list, so then that's a range object, and Python goes, okay, I know what that is, but now I've converted this here. So now let's double this a little bit. Let's go up to 2, 4, 6. So if I want 2, 4, 6, I need to do this right here. So 2, 3, 4, 5, 6. Now if I add a third argument, steps. So that's the equivalent of telling a little kid to count by twos. There's very similarities between programming and a 5-year-old. And so when I do this, now I'm going to be going by 2 from this list. Not counting by 2, stepping by 2, because I'm going to change this and I'm going to flip this on its ear. So now I have 2, 4, 6. But do not associate this that it's counting by 2s. It is not. It is going by every other object here. So if I were to change this to odd numbers, what was that, 6? I'd get 1, 3, 5. Hang on a second. Let's make sure everybody is. Hope things are. Had to keep things interesting. Had. Oh my God. Sorry. Just a friend of mine, old coworker, just. Oh my God, oh my God, oh my God. I need to leave that. So my old coworker, she has so much going on. She just told me that her father-in-law was injured on his hand. Don't want to gross anybody out, but pretty bad. He's doing fine. And she made the joke. I don't know how I've, because I feel this way. I don't know how I feel so busy while being unemployed. I have to say the same thing. August, so tomorrow will be 2 months of me being unemployed, which is crazy, which I do feel busier. So, all right. So that's the anatomy of a range function. So what we're doing here is Venke's solution, which is so elegant, which this is why I like having, we're forming a group and a community and problem solvers, and we're getting smarter together. Look, if you're the only person in the room, there's nobody there's nobody to talk to. There's nobody to bounce ideas off of. There's no one to improve. So this is controlling our slidiness. Our slidiness. So we are starting at 1 because we can't start at 0 because k can't be 0. But it can be up to k, and I'm having to add this 1. So let's kind of dissect this right here. So we just talked about this is exclusive. So I will never get to k because my endpoint is exclusive. So that's why I need, now it can be equal to k. It can less than or equal to. So these are these subtleties and the nuances of making sure you understand the problem and really making these fundamental parts of zero indexing, exclusivity. I don't know why I can't say inclusivity. There we go. I said it. You're gonna notice that you're always gonna be shifting because it has to do with being included or excluded or zero indexing. And those are key basic points, and you're gonna find yourself that you're gonna start being off by 1. That's fine. That's normal until you get very efficient at this. The other return should be outside. The other return should be outside. The other return should be outside. This one? Or should I have another? I know Venke's telling me something, and Venke's being very, very patient. All right, so let's try. I'm not seeing it. Yeah, oh, hang on. I'm not seeing it, Venke. But the other return should be outside. You're talking about outside the for loop? Because I believe Venki very much so. False. We don't even get to there. Boom. All right. Outside should be outside. Because we have to try. What line? Because I'm not seeing where. So I have one indentation. So then I have my other. So I don't need this anymore. So then here's my slidiness. And I'm trying this to capture to make sure this is legal. I don't need that. Then, oh, wait a second. This is what you're talking about. I don't need this anymore. Was that it? Yeah, outside the loop, 21, 25, maybe. I'm delirious. No, hang on, I just deleted something. 21, 25. I didn't go with. So with the for loop, we don't need the try, or with the for loop, we don't need the try. Does it handle? Did you get one that was out of range? Because I was trying to think of everything. Now I also had one that we were indexing last week or the week before, and it was not throwing an error for an indexing issue. See, all right, everyone. So let's visualize. Let's go back to this one right here. So let's say, so right here, we're checking. You have to, when you set up instructions like this is exactly like this. So if I were to set up instructions, let's copy this. So when you're doing algorithmic design, and when you find it, and our human brain makes a decision, like Dax shared that when we're driving, we make 3 corrections per second. Okay. A programming language doesn't have that luxury. It is following your set of instructions explicitly. So let's copy this. And whoa. That's supposed to be that. Oh, here we go. Grab the wrong one. Let's move this over and copy. Put this in here. And paste. Bring this down here. All right. So let's get rid of this. So basically, here's the example. Let's do one here. Just as a visual. Whee! That's awful. Need a bigger eraser. All right. So here's your little stick man. He's going to stand here. Boom, 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 boom. All right. And here's our instructions. We're going to go boom, boom, boom. Let's make this smaller. Make this tight as possible. All right. He's going to step here. He's going to step here, step here, go back up, step here. And if I were to say 3 and he steps here, falls off a cliff, dies. But this is where the try, hey, is there anything in front of you? Try, no, turn around, go back. Same thing here. Falls off a cliff, goes, dies. So you have to be in the process of out of range. So you have to be looking and thinking. So when we get to this one right here and we move over 1, 2, we're good. But then when we get to here and we look over 1, 2, hang on, 1, 2, then we're comparing something that's out of range. So once this happens, we need to stop, because that's what I was saying. So you got it to work without a try and except. I would love to see that, because look, Venki is very, very good at what Venki does, and this, you don't have to be super good at math, but it can help. So I would say that I've gotten better at math. So they help each other. All right. You got to go. All right, Venki. Thanks for coming to hang out. I will see you next time. So, hey, if you're still here, send me the code in Discord so we can look at it. All right. So now we're going to load this up into not Chat GPT. We're going to load this up to there we are. Put this in Leetcode and see how we're doing. Let me make sure I have everything moved over. Let's check the first run through. All right, it passes 1, 2, and 3 are hard-coded. Now let's see if it passes all the other submissions. This is not a good sign. It is still going super slow. All right. Let's check this out. Output false, expected true. Nums equals this, and k equals 3. False and expected true. So what in the world? I thought I got rid of that. There we are. That was my dilemma, because now this should return true. I left in the E. What? All right, I left in the J plus 1. So all right, let's see. And then, all right, so it's not getting down. Let's make sure that we're getting down to these 2. So that's what we need to check. Anybody here with some questions we need to ask? I haven't looked at Discord. Anybody over on Discord? Okay, so it's these 2. Those are the only 2 duplicates. 1, 2, 3, 4, 5, 6, 7, 8, 9, 9. All right. So print I nums I and nums J. All right, let's run this. See what we get. Yep. For some reason, I have an issue where it is not getting all the way to the end. And I realize it is right here. All right, so here's my dilemma. So this is exactly, I did a little bit of foreshadowing. So nums. So here's my issue. Len nums 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That is shocking because this should be okay, one. Okay, wait a minute. Here we are. I'm not even getting the first 9. There we are. All right, so what I was doing is I had my problem where I wasn't looking at my eye. I'm still not getting the first 9, let alone the second 9, because I should be throwing so once I get to out of range. All right. Try continue. All right. So I'm guarding against, but I'm also once I throw an error, once I'm throwing an error, I'm automatically so this is wrong. Here we go. I'm throwing it too early. Bingo. All right, let's go back to what I was doing. Let's go back a second. So the first time it can be out of range. So we solved a couple of things here. So the problem that what it was originally doing is I was constantly looking at these previously indexes because I was doing J instead of augmenting I or our other index from our delta, our difference of J from I. So I needed to go back to add these to here. Now, second part. So there was a lot of problems here. So once this was triggered and the delta was out of range, I was saying, oh, stop. So here's what was happening. Let's go back to this list. Let's clear out everything. And I'll explain to you what all I was doing wrong. So it was a design problem. I was attempting... There was a miscommunication between the subtleties of what we're making as a human decision to where you're handling this with a programming decision. So, all right, let's get this over here. How long have we been on? Because I also have lunch scheduled with some former coworkers, and I have a meeting in about an hour that I just need to have a gap. So let's see. I don't know if I'm going to go to the gym today. So let's see. Oh, let's bring this in here. Paste. Did I not copy this? Oh, I only need this. Copy. Oh, it was this one. Paste. All right. So what I was doing is I was getting to this point. And I was augmenting 1, augmenting 2, augmenting 3. And once that happened, once I had the first out of index, I was saying stop. That's what I'm doing here. And I was saying, oh, you're out of range. You're already looking too far. But I was comparing here to if there were a space out here. And I said, you can't do that. Stop. Well, I still had that one and that one, which really, if you're here, you should stop when you get to there. So this was flawed. And continue. There we go. Then, hey, if you get to the end of this, if you get all the way to the end and then this fails, then, so I'm going to get to the end of the list, not my adjusting, the end of the iteration list. Return true. That is a true what we were doing as a decision. And once I did it, you can see right here, this is 1, 2, 1, 3, 1, 4. So I'm comparing this one to this one, then to this one, then to this one, and then shifting over. And I'm looking inside of that window, that window, that window, and then sliding over and checking and checking and checking until we get down to here, and then I look over. So then I got my 9 and 9. Bingo, found 2 different indices that are equivalent, all the while being inside of our K. So we kind of did this a little bit backwards. We didn't find any matches and then check and see, because we did a little bit of a constraint to keep this as smooth as possible. So we did our double check. We did a limit before we could even do a comparison. Does that make sense? Because what I was originally going to do is I was going to compare everything and then do math. So if this was a list of 1,000 integers and I found a gap with, and I checked them all, and I found 2 matches, but their indices is 100 apart, but my constraint was 20. Why even look for it? So that was why we designed it this way with 2 with a sliding window. So there we go. So now let's place this in the colors medium. So now let's hello Eternal, how are you? Glad to have you here. Our little crew. We're working on a problem. Basically, it's a variation of a sliding window. It's a pretty cool problem, if you ask me. And I love Leetcode challenges. They really challenge you to the max. So let's see. This goes to a continue, and then that stays there. And let's make sure I have this aligned. All right, so I'm running the test case again. And let's see. Okay, now this is failing on which one? 1, 2, 3, 1. All right, now we need to tweak something else. Now it's failing here. Output true, this should be false. So let's see why this is happening. So why in the world I don't see any oh. That's supposed to be false. Why did I change that to true? Okay, let's double check this one now. I even had it as false. Okay. And also. Okay, run again. All right, let me check and make sure I'm not missing anything in chat. And let me check Discord. All right, cool. Cool. Here we go. All right, test 1, 2, 3, 4. Yay, we're doing well. It's judging. I don't think I have a very fast solution because it is still running. Oh, my word. Holy moly. All right. Yep. You are not going to believe the numbers that it just passed in. And K is 35,000. All right. So I do not have. And check this out. We did not have this constraint. So, all right. Or this constraint. What did I... This thing is... We did not do our third constraint, so we need to fix this. All right. There's no reason. Okay. So K... So we need to handle this too. So the length to we're gonna change this around. 2 less than or equal to greater than, so between, let's change this. All right, so hang on. I got to get this. It has to be between, if it is there, and then also if nums, and it said I, right? Nums I no, not in between. So now, all right, so this is, it has to be in between, so I got to think about this. Hang on everyone. All right, so I have a couple of more. So this is fine, but I'm failing the constraints. So these constraints are very important, and you have to think about them. So all right, K has to be, and also less than or equal to. All right, hang on. So these are going to be not. Now, I can do this, but I'm going to get hung up on this constraint. So I was like, they're not going to have this, but they are. Not equal if, we're just going to do this. And I want to do this on one line. And len nums greater than, so it can be up to 105, greater than 106. Or, now this is or. I don't need this. Or K greater than greater than 105. So all right. Because it can be equal to 5. if len nums less than 2, I feel like I want to write that on one line, or k less than 1, or k less than, or k greater than 105. All right, and then if nums I less than negative. Now I'm handling this one. Or nums I greater than 109. Return false. All right. Let's try this. What all did I change? So I changed this to this. The constraints are important, everyone. And then in between the two for loops. Just get rid of that print. Index or indent that. All right, let's try. Did not want to move that use case. That was awful. All right. Let's see, because I was iterating through 35,000. All right, we have, oh my God, it's k output false expected true. Output false expected true. Output false. Here we are. This one isn't that bad. We'll take this one. And then k is 22. Here's nums. And k is 22. All right. Woo! Output is false. And this expected true. So where is this match? Look at that list. How? Len nums. 93. Okay, so the constraint, it's within tolerance. It's in between here. See, this is but it can't be 1 because all right. Num I. Now how is but wait a minute. Nums I has to be between. How is this true and this violates? Oh, if they match. This is in the wrong. This is in the wrong spot. So here's an interpretation problem. Okay. So the solution, not just this can't. So okay. I can. The matches have to be between. So I'm putting this here in between. So I'm saying this fails on the first check right here. But it's only if they match, they also then have to be here. Let's get rid of this. Okay. So let's comment this out. So and nums I. Okay. And I'll explain this in just a second. There we go. This is an order of operation problem. Let me make sure. Let me try this again. Shoot, I thought I was really close. Output false, expected true. Nums length constraint. Len nums. How? Oh, not hums. Nums. How big is 93? So that's fine. Or. Okay, why isn't... This should be fine. Nums I. So I have a list here. Where does it match? It doesn't go back far enough. All right, I need to start wrapping up here. Any pressing questions? Any pressing of anything? And I'll keep looking at this. I want to try if so we can make this list shorter. How would I do that? So I only want to print out. So also, hang on. If nums I greater than, was it 109? 109 or nums I less than 109. Continue. See if we can get the output here. Huh. Well, I'm going to have to tweak this. All right. I think everybody's starting to drop. So we'll start to wrap this up. Please make sure you're joining the Discord server so you're getting all the help that you need and deserve. And I will see you all tomorrow. Hopefully, this is more than likely just an order of operation problem because, let's see, I think this is legal. I can't quite remember. Pretty sure. No. I know this is legal. Lists, you can do this too. There we go. Yeah, it's legal, so we can see everything. All right, so I'm gonna work on this. It's probably a constraint problem or an order of operations, because those typically are just where you have issues. So glad to have everyone here today. I hope everyone has a good rest of their day. And for those of you at the end of the day, I hope you sleep well and have a great start to your morning tomorrow. And we will see everyone next time. Bye, everybody. Thanks.